All right, guys, here's our first example. Um, a couple things I do want to say before we get started on this is always, always, always draw a picture that represents your situation. Okay, so to kind of piece through what we are given here, as we read this, we're given that the variable x is normally distributed with a mean of 11 and a variance of 25. Okay, so to kind of sketch this out right now to see what we have, you're looking at a bell curve. Now, these are not the easiest to draw, but just do your best. It doesn't matter. Okay, and on these bell curves, the bottom line is going to be the axis for your variable. So since our variable here is x, that's what I'm going to place there. And then these bell curves are symmetrical, so the left and the right side match each other. So do your best to put this line right down the middle, and this is where your mean is going to go. Okay, so what I like to do is I like to put mu at the top. That's a Greek letter that represents mean. And so I place the 11 there because that's what's given. Now the second piece that I want to look at to include in my little picture that I've got is the probability and the x value that we're looking at specifically. So like right here. So we're looking at 18. So 18 is definitely to the right of 11. Okay, so think about this as an x-axis that's continuous. And they give us a probability that, actually, we're trying to figure it out. They don't give it to us. So we're trying to calculate the probability that x is less than 18. So what I'm going to do is shade in everything that is to the left of this 18. Okay, so think about this bell curve, and all of this is what I'm trying to figure out. So to give you a little background on what it is that we're trying to find, everything to the left of this mean is 50%, okay, or like 0.50. So we know that our answer is going to be greater than that because we exceed past that 50%, okay? And so the first couple of things that we try to figure out when calculating a probability is to find the z-score, okay? And we have a formula that is in your notes that you guys are going to see that looks like this. And this formula allows us to take this normal distribution and to create a standard normal distribution. So what I do is underneath this diagram, under the x, I put a z that correlates to these z-scores. So the mean is always going to be a z-score of 0, and we are trying to figure out the z-score for 18 right now. So if we come back over here to this formula, 18 is our x value. We subtract our mean, which is 11, and we divide by the standard deviation, not the variance. So remember, the standard deviation is the square root of the variance, okay? Now, all I do is I type this directly into my calculator, and you want to get a decimal, okay? And the decimal that you come up with is 1.4. Now that's not our answer, but that is going to lead us to our answer. So what you guys do next is you look at that crazy complicated probability distribution table, okay? And I'm gonna scan over to it real quick. And we are looking for a z-score of 1.4. So as I look on this table, I'm looking first of all in this column, okay, for 1.4. And I see it right here, okay? And there's no other decimals past 1.4 in our z-score, so it's 1.40. So this right here is the probability that we are calculating. And notice that these probabilities correlate to this picture right here. They are always going to tell us the probability of a shaded region to the left of some number that lies to the right of the mean, okay? So if you flash back now to our problem, which was right here, I believe, yep. Okay, so we found that probability, and and we set this up just like this. So the probability of x is less than 18. We can then write this. You're going to see this in my worked out solutions for my homework. I always rewrite this using the z-score probability, which because they're the exact same thing, and that's why on this table in this picture, I put the z-scores directly under the values that they have. So even under this 18 right here, I'm going to write 1.4 just to show you guys that those are the exact same piece. We're just standardizing it, meaning we're just giving it a different name so that it's easier for us to use. And so that value, like we just found in the table, we said was 0.919, okay? And we always want to round to 3 significant figures. So that is our answer for that first problem. Ta-da!